Hello, boys and girls. We're going to be on page 23 of our Unit 5 packet. And today we're going to be talking about multiplication and addition properties. Now, properties are like helpful rules. So these properties or these helpful rules that we're going to be learning about are going to help us work with expressions and kind of equations, but more expressions. So we're going to take a look at three different properties, three different helpful rules, and keep in mind that these rules only relate to multiplication and addition. That's it. Okay? All right. So the first property we're going to look at is called the commutative property. Now, I want you to write this down with me. Commutative has a word in it that you might be familiar with, you might not, and that word is commute. Right? If you commute, that means you're like moving from one place to another. So commute means to move. That's going to be an important part of this property. So what we're going to do is we're going to take a look at a couple examples and see what's the same and what's different, and then we'll see if we can explain the property. All right, so let's take a look at these two expressions. They're equal to each other, 7 plus 11 and 11 plus 7. We also have these two expressions, 8 times 3 and 3 times 8. Well, what's the same about these two examples? It looks like what's the same is that the same numbers. So in the first example, we have 7 and 11, and the second example, we have 3 and 8. All right, well, we can also see like 7 plus 11 is 18, 11 plus 7 is 18, that's good. 8 times 3 is 24, 3 times 8 is 24. Each expression, or both of these expressions, have the same value. Same value. What's different? Well, it looks like one is multiplication, one is addition. I mean, that's one thing you can notice. This is addition, this is multiplication. But one thing that's different too is that the numbers are in a different order. 7 plus 11, 11 plus 7. 8 times 3, 3 times 8. So what's the difference? Different order. So that's a really important part of this property, because it looks like even if you change the order of the numbers in addition and multiplication, you still get the same value. They have the same value. So let's write that down. That's actually what that property means. Commute means to move. So if the numbers move in addition and multiplication, the value stays the same. So in multiplication and addition, if you change the order of the numbers, the value stays the same. Sorry, I just had a guest come in, so I had to pause it for a second. I'm going to start this up again. If in multiplication and addition, if the order of the numbers change, the value stays the same. So if we did like 2 plus 4, it's the same as 4 plus 2. We change the order of the numbers, the value stays the same. So for example, if I had like 15 times 23, without even figuring out the answer, I know it's the same thing as 23 times 15. So I know that these two are equivalent, and I know they're equivalent because of the commutative property. When you change the order of the numbers with addition and multiplication, the value doesn't change. All right, so that's the first one, commutative. Commute means to move. The next one's called the associative property. And there's another word, kind of like the last one, hidden in there, okay, that you may have heard of before. And that word is association. So if you think of the NBA, that's the National Basketball Association. The National Basketball Association is a group of teams that play professional basketball. So an association is like a group. And in math, to show groups, we're going to use parentheses. So that's how we show groups. So let's check these examples out. So we have two expressions that are equal to each other. One addition, one multiplication. So let's first look for what's the same. It looks like 623, 623, 485, 485. Looks like we have the same numbers. We have the same numbers. And it looks to me, too, like they're in the same order. Like those numbers didn't move around. 623, 623, and then 485, 485. Okay. Let's think about, let's find the answer here. Let's see if the answer is the same. So we do parentheses first. 6 plus 2 is 8. Plus 3 would be 11. And on this side, we do the parentheses first. 2 plus 3 is 5. And then 6 plus 5 is also 11. Let's see if this word is the same for multiplication. 4 times 8 is 32. Times 5 is 160. And then 8 times 5 is 40. And then 4 times 40 is also 160. So it looks like the two expressions have the same value as well. So what's different? Same value. What's different then? Well, if you look carefully at each one of these, you can see that the numbers are grouped differently. The parentheses have moved from one pair of numbers to another. So 6 and 2 were grouped first in parentheses, and then 2 and 3. So what's different? Different groups. Okay? Or parentheses. Yeah. So we grouped the numbers differently, but that didn't change the answer. And that's what the associative property is. If we group the numbers differently in addition and multiplication, the value doesn't change. So let's explain the property. In addition and multiplication, when we group the numbers differently, the value stays the same. That is called the associative property. So just another example with some crazier numbers. So if you did like 72 times 11 times 34, I don't even have to figure out the answer to that. I know, based on the associative property, that if we kept the numbers in the same order, 72, 11, 34, but just grouped them differently, I know that we'd get the same answer. So these two are equivalent, and I know they're equivalent because of the associative property. We just group the numbers differently, and it is multiplication, so we're good. All right, the last one's a little different. It's called the identity property. This one's a little easier to see. What we do here is identity. Well, identity, I think of like when you look in the mirror, you see like your identity, your identical self. So when I think of identity, I think of like yourself, who you are. And so you can see in these two expressions, or in these two equations, what we start with and what we end with is the same. 8 and 8. Okay, so what's the same? We start and end with same number. Okay, so if we add 0 to any number, you're going to get that same number back. if we multiply any number by 1, we get that same number back. So the only thing different really is that in addition, you're adding 0 to get the same number back. And in multiplication, you're multiplying by 1 to get the same number back. That's really the difference between the two. So let's explain the property. We'll say if we add 0 or it should be or multiply by 1, we get well, you know what? If we add 0, multiply 1, the value of the number doesn't change. That's what we'll say. That's why these, multiplying or adding 0 or multiplying by 1, those are so easy because you just get the same number back. The value of the number stays the same. So again, just a kind of crazy example. If we did like 17,234 times 1, you can do the answer really quickly, and it's really easy because of the identity property, you get the same number back. Same thing if we added 0 to that number, you get the same number back. That's called the identity property. When you think identity, you think of like itself. It gets itself back. Okay, let's go to the next page. So what we're going to do on the next page is we're going to work with some of these properties here. I'm just going to jot down the ones we already know so far. So we have the commutative property. That's the one. Commute means to move, so we're talking about the order of the numbers. The associative property. Associations are groups, so we're thinking parentheses, associative. And then there's the identity property, which is adding 0 or multiplying by 1 doesn't change the value. All right, so what we're going to do is we're given two expressions. We're going to see if these two expressions are equivalent, whether they have the same value. So the first one is 15 plus 6 and 6 plus 15. Well, all that changed was the order of the numbers, and this is addition, so they are equivalent. They're equivalent. I'm just going to abbreviate equivalent. And the reason why says what property is applied, it's the commutative property. Commutative. Okay. The reason why these are the same, I don't even have to find the answer, is because same numbers, different order with addition. Okay. All right, let's check out the next example. Let's look at what we have here. 5 times 6 times 3 with 6 and 3 group, and then 5 times 6 times 3 with 5 and 6 group. So we have the same numbers. They're in the same exact order, but the only difference is that the numbers are grouped differently, and it is multiplication, so these are equivalent. And the reason, I'm just going to use a different color so it stands out better. The reason these are equivalent is because of the associative property. We just grouped the numbers differently. We didn't change the order of the numbers. We didn't change the numbers. We just grouped them a different way. And it is multiplication, so that works. All right, next one, it says 9 times 1 and 9. Well, when you multiply by 1, you don't change the value. You get the same number back. You get itself back, and that's the identity property. So these two expressions, although 9 isn't really an expression, those two are equivalent because of the identity property. All right, let's try the next one. So we have two expressions, 12 times 4, 4 times 12. Same numbers, different order. And it is multiplication. Same numbers, different order. That's going to be commutative, right? Because the numbers changed order, but the answer is still the same. The value didn't change. So that's commutative. Sorry, I just had another special guest. And so let's check out the next one. So let's look at the numbers here. We got 20 minus 12 minus 3 with 20 minus 12 grouped. We have 20 minus 12 minus 3 with 12 minus 3 grouped. Now, it might look like the associative property, but these, I can tell right away, are not equivalent. It looks like the associative property, but it's not because there's no associative property for subtraction. Okay, so there's no associative for subtraction. There isn't, or division. So if you ever see something that looks like associative property, but it's addition, or division or subtraction, it's not equivalent. Not equivalent. All right, next one. We got 34 plus 0 is 34. Well, these have the same value. All we did was add 0. You get itself back, so that would be the identity property. Equivalent, and that's the identity. Identity. All right, let's check this next one out. 12 divided by 3, 3 divided by 12. Same numbers, different order, which seems like it would be commutative, but this is division, and there's no commutative property for division. It's only for addition and multiplication. So we'd say this is not equivalent. And sort of similar to the example that came to before this, we'd say there's no commutative for division. There isn't one. These properties are just for addition and multiplication. All right, let's check this one out. It's got 15 plus 5 plus 8 with 5 and 8 grouped. We have 15 plus 5 plus 8, 5 and 8 grouped. Same numbers, same order, different groups. When we think groups, we think of associations. That's going to be associative property. And because it's addition, we're good. If that was, subtraction or division, even though it looks like the associative property, it wouldn't count. But since this is addition, that counts. All right, nice smattering of colors here. Looks lovely. All right, let's check this one out. We got 35 plus 17 plus 43, 35 plus 17 plus 43. It looks like the numbers are grouped differently. We're using addition. So looks like that's a back-to-back associative property. Associative. So we're just abbreviating equivalent, but we're writing the whole property out just to practice spelling those because I've seen some zany spellings of these through the years. So we're just going to practice that for now. All right. So now that we have a better sense maybe of the properties, we're going to take a look at how maybe we can use them to write expressions. So we look kind of farther down the page, we see, there's still marks there. All right. It says in a recent season, the Kansas Jayhawks had 15 guards, 4 forwards, and 3 centers on their roster. Write 2 equivalent expressions using the associative property that can be used to find the total number of players on the team. Well, when we think associative property, we're thinking groups because association means a group. So we're probably thinking we need to use parentheses here. All right, so we want to find the total number of players. So we'd probably add those up, right? 15 plus 4 plus 3. Now we want to use the associative property. So we're going to group these numbers in a certain order. Let's 4 plus 3, okay? Now we're going to write an equivalent expression that has the same value using that property. So with associative property, it's key to keep the numbers in the same order, 15 plus 4 plus 3. But we're just going to group them differently. So instead of grouping the 4 plus 3, we're going to group the 15 plus 4. Answer doesn't change. The value doesn't change. All we changed was the groups. So those are 2 different expressions using the associative property. All right, let's check this one out. We got Brandy. Brandy earned $7 babysitting, $12 cleaning out the garage. Write 2 equivalent expressions using the commutative property that can be used to find the total amount she earned. Commute means to move. So we're going to write one expression. It's just going to be 7 plus 12. Okay. So when we use the commutative property, all we would do is change the order of the numbers. 12 plus 7. So those are 2 expressions. They're equivalent. I don't even have to find the answer. I know they're equivalent because of the commutative property. Okay, this one here is a little bit more advanced, but same ideas here. It says use a property to make this problem easier to solve. Well, right now it looks a little tricky because we have 1/3 times 9, or 11 times 9. If we're going to multiply a fraction, we'd probably want the other numbers to be fractions too, so I'm just going to change those to fractions. And when we multiply fractions, sometimes we can simplify, but if I look at 11 and 3, I cannot simplify those. However, if that 9 over 1 was next to the 1/3, we could simplify that. So I wonder if there's a property that says we can change the order of the numbers, but the answer will stay the same. If we can move the numbers around, well, move, there's another word called commute means to move. So I wonder if we can use the commutative property to move that 9 next to the 1/3. And I believe we can. Because it's multiplication, we can move the 9 right next to the 1/3 and not change the answer. But now we can simplify. You can see there's a 3 and a 9 right here. So we can do 3 divided by 3 is 1. 9 divided by 3 is 3. There it is. That's going to make it a whole lot easier to solve. So we'd have to do 1 times 3, which is 3, times 11, which is 33. And then just 1 times 1 times 1, which is 1. And you get 33. So even though it started off looking kind of difficult, using the commutative property helped us make that easier. All right, so these ones are kind of neat. So at least to me they are. It says use one or more properties to rewrite each expression as an expression that does not use parentheses. So right now all of these use parentheses. And what we're going to try to do is we're going to write the expression without using parentheses. So let's look at this one first. We can't just get rid of the parentheses. What we'd have to do is move them around maybe to make it so we can add something together. So we can't do y plus 1 because we don't know what y is, but we could do 1 plus 4, but we can't because the parentheses are around the y plus 1. We'd have to do that first. However, there is a property called the associative property that says if we keep the numbers in the same order and just change the groups, it doesn't change the value. So let's do that. Let's keep the numbers in the same order. Let's just change the groups. Again, the value didn't change. And we can do 1 plus 4, which is 5. And because there's only one number left, we would be able to get rid of the parentheses like that. So we would just wind up with y plus 5, which is nice. Okay, in the next example, we have 3 plus x plus 5. Now, I can't add together 3 plus x. I'd want to add together 3 plus 5, but they're so far away. I wonder if we can get them closer together. So I'm thinking, like, if I can move that 3 closer to the 5, that's going to help us out. And we can move numbers around when we add or multiply because that's the commutative property. So what we could do here is we can move the x and the 3. We can change the order. Didn't change the groups yet. We just changed the order of the x and the 3. That's the commutative property. And now, maybe you can see this, now we can change the groups. So we'll keep the numbers in the same order. We'll just change the group. And we can do 3 plus 5. That would be 8. So this would just be x plus 8. Okay. All right. So using the properties. So this one here, similar to the one we just did, 6 times r, we can't do it because we don't know what r is. However, we can get that 6 and the 7 together. We can multiply 6 times 7. So let's change the order of the r and the 6. Just moving them around using the commutative property. Didn't change the value, just change the order of the numbers. Now, we can change the groups. We'll keep the numbers in the same order, and we'll just change the groups. I'm just going to get rid of that 24 for a second. All right, so right now we can do 6 times 7, which is a 42. And there's no more parentheses because we can do 6 times 7 and get rid of the parentheses. All right, so that's when the properties can be really helpful. You can use them to help you simplify expressions. You can also use them to help you make them easier to solve. All right, I hope you are having a great day. I hope that you enjoyed this video, and I hope to see you soon. If you have any questions, let me know. Have a great day. Bye-bye.